Now in this topic, we know about the binary fraction IEEE754. What is the binary fractions? When you write it in the binary form, you write in the digital 0, 1, 0, 1, 0, 1, 1, 1. This is a binary. You can convert the binary form to the integer value or decimal value. But some students ask me how to write it in the floating points when we have example pi value. The pi value is 3.14. This is a pi value. How to write it in the binary form in pi value? The technique that is the binary fraction. Here the binary fraction, the binary we know the weight in each digit in the binary is in form 1, 2, 1, 2, 4, x. This is the weight in each digit. Example, I write the number is this. I write the number is this. Example here. The number is 1011. 011, 1011. The 1011 is a 1, this is a 1. The next one here, this is 2. And 0 is represent 4. And 1, the left, this is represent x. This is a totally is x at 2 at 1 is this 11. Here is 11. And for the when you write it in the binary or after the 1, you can write the digit by example the next digit in the right hand side. You write it in 2 power minus 1, 2 power minus 2 in this form, 2 power minus 3, and 2 power minus 4. This is a write it in this form, and the number is will be reduce the number, reduce the size by the 2 power minus n. Here for 2 power minus 1 is 0.5, and here 2 power minus 2 is 0.125. 2 power minus 3, this is 0.625. Here, example, I write it in the binary. Example, I write it 1.101. This is a binary. So the output is 1 at 0.5 as 0.5 is 0.65. here this is here this is this is a long value. It should be 0.06625 like this. So the output is 1. Yeah, this is a output. This is a result. Yeah, because this is technique, this is a binary fractions. The binary fractions for this example, this is wrong because it should be 0.0625. 0.625. So the binary fraction, not this is easy for convert in the binary, and maybe when you have more significant, when you have more number in the bit, the more number in the significant, you could write it in the binary form. It is a very large. So IEEE, they think the standard for convert from the binary to the floating point that is called 754 IEEE standard. The 754 IEEE standard, this is a introduced in the first time at 1985. Now it's used in the computer system until today. By the IEEE 754 have three part bit. By the first left hand side bit, this is the sign bit. This is a positive part or negative part in the sign bit. And the second part of the bit is have about the 11 bit. 11 bits. This is related to the exponents. It's the exponential bit. And finally, in the third part, we call the matrices. The matrices have the number of bits at the 52 bits. The IEEE 754 is written in from the exponential part in the value. So when you look at the number, it's not growth like as the linear growing. It's growth like in from the exponential, and maybe it's in the some small value. Maybe it is a skip some value because it's related to the exponential growth. You can generate the value by do the simulation in this website. You can click here this to enter the website to generate the random generate the floating point value by simulation. Example, I write it t.14 to the binary. This is the actual value, and here this is the binary in form the IEEE 754. I write is exactly 3.140000, but the value is generated not the same because it's effect from this that occur from the exponential effects from the IEEE 754. How you can simulate here and increase the value. The IEEE 754 does have about the problem about the growing not do the like as the exponential, like as the linear is do like as the exponential, but and IEEE 754 have in some ambiguities. The ambiguity about the -0 will occur when you generate the value. For the -0 is the same of the 0, but sometimes generate output -0 from calculation. But on display in computer is convert from -0 to 0. And about the infinity value have a problem, and generate the NAN that is come from not a number. From the infinity and not a number have effect in the computer system. Example, you calculate the value when you calculate square root. This is square root 0, and square root 0 is maybe generate the error. For the error, as I will tell you in the next section, next topics. In computer systems, sometimes have most of the computer system when you write code, this is you should write the problem about the boundary, the value in general and in writing in the computer program. For the most new student, the declaration the variable in the integers. The integer, we know integer is not floating point value. But when you write the code, today you write the code in Python, in the advanced language. The advanced language control the variable range, and also in your application use the variable scope or range is not very large. When compared from the very old programmer or old computer system, example, in 20 years ago, I write a code in C language. I declaration integer in 16-bit, integer in 8-bit. That is an integer 8-bit and 16-bit have limitation in the boundary. For today, we use integer 32-bit or 64-bit. You look it is a very large, and you not realize about the limitation of the boundary. Okay, this is an example. The computer and only the IoT today, some IoT system run it in the 16-bit, and some IoT system run in 8-bit. For the 16-bit have the number is 2 power 16. That is a boundary when write it in the binary, in the decimal is 0 to 65,536. And in the positive and negative part, it is split in two parts. It have about minus 32,000 and positive 32,000. And for the 32-bit system, the boundary, the number is 4 billion. When you declaration in the Python, maybe you in the scope of 4 billion, and you don't realize about the limitation is 4 billion is very large. And for the 64-bit, this is, I think it's over trillion. So when you write the code, you don't worry about the scope or limitation number, except you bring this computer to calculate very large number. Okay, I show you the problem by use the C language code. I think you should open the online GDB and put this code to online GDB and do the simulation. And in this course, I declaration the short integer. The short integer have about the 16 bits that have boundary when the number is moving up until to hit the maximum boundary here to 32767. This is a maximum boundary. This is a moving back to lowest boundary. When move to hit the top, we'll move it back to under automatically. So return to zero when you hit to the top of the boundary in the numbers. Okay, now the next problem about the NA and INF and NAN. What is NA? NA is a missing value. Example, you create a form, example form about the questionnaire. User can fill or not fill in the form when user don't enter or write it some message in the form that is generate NA output. And NAN is a complex number and real number in imaginary parts that when you calculate sometimes it will generate not a number when generate the errors. And for infinity, when you calculate by do the multiplication, do the subtraction, over the range. This is generate the infinity value. Example, I show you the INF. The INF, this is example here. I generate by 1.0 division 0 here, get the output infinities. And here 1E307. This is a maximum boundary in the 32-bit number. This is what is the meaning in this? This is 1 and 307 0. 1 and you have a number 1 and 307 0. This is a very, very large number. And I multiply by 100. So it's very, very huge, the number. So the output is generated infinities like the first. So it is generate very small and it generates very maximums. And when I do the square root -1, here is generate NAN. And you can check the NAN, INF in the C language by using the functions INF to check the error on NAN and INF. Okay, now we move to the summary for this chapter. I think this chapter we will know and realize about the number in computer system, and you know about how to generate the random value, how to do multiplication and subtraction in binary, and about the IEEE754, and finally about the error in when you calculate in the computer system. Okay, thank you. Bye bye. สวัสดีครับ